Hello everyone. Today we're going to review the 4 special segments of triangles that we talked about before Thanksgiving break. You'll find this file in the folder for today under special segment sheet. Alright, so first thing we talked about from, I want to say 3 weeks ago? Yeah, 3 weeks ago. We had what were known as the perpendicular bisectors, with the implied bit that these are going to be segment bisectors. And our perpendicular bisectors are essentially going to be segments that bisect a side into corresponding and congruent segments while forming a 90-degree angle with the base itself. When we get 3 of these perpendicular bisectors together, they give us the point of concurrency known as the circumcenter. The circumcenter is going to be located in the position such that it is going to be equidistant from each vertex. So if we look at our little sample graph over here, we're essentially saying that if D is our circumcenter, then segments J, I, and K are all congruent because D, our circumcenter, is equidistant from each vertex. The second special segment we were talking about is our angle bisector. Our angle bisector looks to bisect, cut in half, an angle that it goes through. How it interacts with the opposite side doesn't matter to us necessarily. All that matters is that we have an angle that is bisected into equal halves. When 3 angle bisectors have a point of concurrency, it is known as the incenter. And the incenter is equidistant from each side at a 90-degree angle. So we look over at our sample. We have point D as our incenter. We're saying that segments Q, R, and P are congruent, and each of them makes a 90-degree perpendicular angle with their side. The third segment we're talking about, or that we talked about, was our median. And our median runs from the vertex to the opposite side going through the midpoint. So our median is still going to create 2 segments on opposite sides of the point of contact that are going to be congruent to each other. And when we get 3 medians together, we have what is known as the centroid. Now the centroid creates certain relationships. Specifically, we can have the short segments are going to be equal to half of the long segments. The short segments are also going to be equal to 1/3 of the full segments. Our long segments are going to be equal to twice the short segments, as well as the long segments are equal to 2/3 of the full segments. So what do I mean by short, long, and full? If we look at our sample here, there's no centroid marked, so we're going to put a little G right there. What we're saying is that if segment BD is our full segment, then segment BG is our long segment, and segment GD is our short segment. Creating the relationships such that if we have segment GD, that's going to be equal to 1/2 of whatever segment BG is, while also being equal to 1/3 of whatever BD is. Whereas the long segment, known as BG, is equal to twice whatever the short segment, GD, is, as well as 2/3 of the full segment, BD. The last special segment that we talked about before we went on break was known as the altitude. And our altitude serves to connect a vertex to either the opposite side or a line containing the opposite side at a 90-degree angle. When we get three altitudes together, these are known as the orthocenters. But they don't have any specific properties. Rather, their location varies. In that for an acute triangle, let's change up the colors real quick. In an acute triangle, the orthocenter is inside. So acute, inside. If we're talking about a right triangle, then the orthocenter exists on the triangle. And finally, if we have an obtuse triangle, the orthocenter exists outside the triangle. So we can use orthocenters and altitudes to quickly identify if we have an acute triangle, a right triangle, or an obtuse triangle without actually measuring the angles. So if we take a look at our little sample over here, if we assume that G is an orthocenter, then we can say that this is an acute triangle because G is inside the triangle itself. And orthocenters are only going to be inside acute triangles. That, folks, are the 4 segments that we talked about before break. As always, if you have questions, please email me or ask them during our Zoom chats. Take care.